the School of Sociology seminar series. This is the first of our seminars in this semester, and I'm really delighted to welcome Dr. Alberto Caimo from the University of Lugano in Switzerland, and one of our own PhDs here in the School of Sociology, and also a member of the Dynamics Lab in the Geary Institute, Paul Wagner. And their focus is on researching social networks for climate change policymaking. And so there's two papers going to be presented today. Alberto is going to give an introduction to a very exciting new methodology for modelling social networks, and that is the ergon modelling approach, Bayesian ergon modelling approach to network analysis. It's a statistical model that he'll explain with a view that the audience is quite a mixed audience with different backgrounds, disciplinary backgrounds, so hopefully that will be of interest to a lot of people here. And Paul is then going to provide a really nice empirical example, I suppose, of the application of ergon modelling in his PhD research. I'd just like to note that Paul is funded under the PRTI Simulation Sciences PhD programme. Actually, Alberto is here courtesy of the same PhD program, and that's funded under PRTI, so just for noteworthy, for noting that in the HEA. Okay, so the way in which we're going to run the seminar this afternoon, Alberto is going to make his presentation, which is going to last about 35-40 minutes, and then there'll be some time for questions and answers. And then immediately after that, Paul will make his presentation and question and answers, that paper, and maybe others that arise at the end of the seminar. Okay, let's get started.
My name is Alberto Caimo, and I'm a postdoc researcher at the Social Network Analysis Research Center in Lugano, Switzerland. Basically, my talk is going to be about Bayesian social network analysis. So I will give you an introductory overview of the issues related to this exciting research area. Okay, so this is the outline of my talk. I will briefly introduce some notation, basically. So I will talk about social networks and how social networks can be represented mathematically through mathematical graphs. I will briefly introduce exponential random graph models. There are a very popular and well-known, widely used family of models, statistical models for the analysis of social network data. And then I will, again, briefly introduce some concepts about Bayesian analysis of exponential random graph models. Then I will go through very briefly through a toy example just to show the main features of the analysis, the Bayesian analysis. And then I will advertise a little bit my package in our package. Okay, so first of all, social networks. So social network data are basically relational data. So we observe, we have a set of actors that are represented by a set of nodes in our mathematical graph, in our network graph. And then we have connections between actors. These connections are represented by links in the network graph. So basically, the entire connectivity structure of a random network can be represented by the adjacency matrix, which is encoding the presence or absence of a link between any pair of actors. We are generally suppose that this adjacency matrix is made of is composed by binary elements. So we have that each element of the adjacency matrix can take value 0 or 1 depending on the absence or presence of a link between two nodes. The adjacency matrix can be symmetric if we are dealing with undirected networks, and can be asymmetric if we are dealing with directed graphs. Self-loops, so loops connecting the node to itself are not allowed generally. Nodal and dyadic covariant information, so information on the actors, so for example the gender of some students in a school, can be used as information to form the network statistics that we are going to include in our model. But also dyadic covariant information can be used, like for example geographical distance between two nodes. All these kind of information can be used in order to, in some sense, try to model the topological structure using these information. So these are two examples of networks. So in the first line, in the first row, we see an undirected network and the corresponding adjacency matrix. And the second row is basically we have a directed network and a binary asymmetric adjacency matrix. Okay, so I think this is very easy to understand. So basically, exponential random graph models is representing a flexible family of statistical models designed to make inference about whether certain effects associated to some network statistics are more or less common than expected by chance. So this means that the probability of the network statistics being present in the network is expressed in terms of parameters. Network statistics with positive parameter value have greater than chance probability of being observed in any network presented by the model and vice versa. So positive value of the parameter indicates a strong evidence that that type of network statistics is important in order to explain the connectivity structure of the network, and vice versa. If we observe a negative parameter value associated to a certain type of network statistic, we have information that that network statistic is not present, is not very common in the connectivity structure of the network. So the connectivity structure of the network, the connectivity structure of an observed network Y can be explained by the relative presence of a set of network statistics S of Y. The likelihood, so the model, the definition of the model of an RGM is represents the probability distribution of Y, so the adjacency matrix, given a parameter theta. So basically, an RGM is defined as the probability of Y given a certain number of parameters, which is equal to the exponential of theta, which is a vector of parameters, times S of Y, which is a vector of network statistics that we are interested in, minus a normalizing constant. So basically the model is specified by selecting a set of network statistics that we suppose are important in order to explain the connectivity structure of the network, and then our aim is to estimate the parameter value corresponding to each of these network statistics. The value of the parameter associated to each statistic is giving us insight about the importance of the network effect in explaining the observed connectivity structure. Gamma of theta here is a normalizing constant, which is generally intractable in the sense that it cannot be computed easily as we insert in the model some network statistics that are quite they are making the computation of the likelihood quite difficult. So this is generally true when we analyze networks with more than 20 nodes, and we include statistics like triangles, 4 cycles, or higher level network statistics that are not just trivial dyadic statistics. So for this reason, the likelihood here is said to be intractable. So here I got just a few examples of commonly used network statistics. So generally we are interested in modeling the density effect, so the number of edges. If we are in a directed network case, we are interested in modeling the density of the mutual edges. So we would like to understand how many of these links that are observed in the network are actually reciprocated links. If the reciprocity effect is important, we expect that the adjacency matrix will tend to be symmetric. Then we also include statistics that are based on the degree distribution of the network in order to, for example, evaluate the popularity effect in the network. A number of clicks, cycles, in order to measure transitivity effects and so on. So these are just a few subgraph configurations that are corresponding to some of the network statistics that I wrote there. So the number of edges in a directed case, mutual edges, two stars type of configurations, triangles, and so on. So basically, if we want to have some insights about whether some of these effects are important in the network, we just need to include network statistics counts in our model. So here, basically, in our SOY. So classical inference is based on the maximum likelihood estimation, where we seek to the parameter value that maximizes the likelihood of the model. Performing maximum likelihood estimation for parameters in RGM is challenging, as we said, because we don't know, we cannot evaluate this distribution directly in the most interesting cases. But Geyer-Thompson, there's a paper about Geyer-Thompson which provides a general algorithm that can be used for approximate the likelihood and therefore to estimate the parameters. This is just an example. I mean, there are many other possible approaches. Bayesian social network analysis. So now the issue is that in the classical inference we are targeting the likelihood, and we would like to we consider the parameter fixed, and we would like to maximize the likelihood based on a fixed value of the parameter. In Bayesian inference, we are targeting a posterior distribution. So we are targeting a distribution which is the probability of the parameter theta, which is now a random variable, given the data. So we are targeting a conditional probability of the unknown quantities, for example the parameters, given the data, after observing the data. So the Bayesian framework is made of these three steps. Specify a probability model for all the unknown quantities, for example the parameters. So we specify a prior density for the parameters. We update the knowledge about the parameters through the Bayes theorem, so we get the posterior density through the Bayes theorem. And we target this density here. Then we can evaluate the fit of the model to the data and the sensitivity of the conclusions to the assumptions. So this is the general framework for Bayesian inference. So we observe a network Y, we observe that we are focusing on its connectivity structure. Then we have model specification. So each model is defined by the selection of statistics that we are interested in. For example, number of edges, number of 2 stars, 3 stars, number of 4 cycles, 5 cycles, 3 cycles, or triangles, and so on. So the model is specified by the statistics that we would like to include in the model. The choice of these statistics is generally application driven, because you can potentially include a lot of statistics that the set of all possible statistics in a network is potentially is huge. So it's generally, for example, in sociology, is often the case that we are interested in the modeling the density, so the number of edges, the number of some statistics that are associated to the in degree or degree distribution, and also statistics associated to the transitivity effect, so triangles and this kind of configurations. Then the third step is to try to estimate the doubling tractable posterior distribution. In this case, I used the notation, I included theta, and m indicates the model, because in some cases we may have a set of competing models, each of which is defined by a different set of statistics. So we would like to select the best model and then estimate the parameter associated to that model. So in this case we have two unknown quantities, the model and the parameters. In Bayesian framework we have a fully probabilistic framework to do that. So we are targeting a probability distribution. Then step 4 is just, probably it's a better step from step 5. Step 5 is just about model selection. So we would like to estimate the probability of the model given the data and the parameter. And parameter inference, so we are focusing on the posterior parameter distribution. Once we have estimated the best model and the parameters associated to this model, we can perform goodness of fit diagnostics. So basically we can simulate from our estimated posterior density new network realization, so we can sample basically and simulate new networks, and then we can compare these simulated networks based on our model, estimated model, to the observed network. This comparison is done in terms of high-level network statistics that are generally not included directly in the model that we have already selected. So generally the model that we select at step 2 is a parsimonious model, so we are interested in just very few specific effects that may have been driven by theoretical considerations. But then we can perform goodness of fit and see how the model estimates are basically fitting the data. So why Bayesian social network analysis? Because it's a reliable, systematic, probabilistic assessment of model and parameter uncertainty. So all the uncertainty is modeled through probability statements. Rich diagnostic information about the unknown quantities, controlling for exploration of prior assumptions. Bayesian hierarchical modeling is also very effective in order to model complex heterogeneous data that are typical in this kind of context. So an important feature here that I would like to stress is that we can include in this framework prior knowledge about the effects that we would like to include in our model. So, for example, if we are interested in modeling the density, reciprocity effect, and transitivity effect in our network, we could include our prior belief about these parameter values. So, for example, in real-world networks, we already know that generally we have a negative density effect. Using a Bayesian framework, we can actually set up a prior which is taking into account that probably the observed network is sparse and it has a low density. So basically we have the likelihood, the RGM likelihood, the model, which is intractable because the normalizing constant cannot generally be computed. And then we go from the likelihood to the posterior. So we update our knowledge of the parameter via Bayesian theorem. But then we have two intractable quantities. So we have the likelihood, which is intractable, and the model evidence, which is generally intractable. Model evidence is the probability of the data given the model. So basically, this is called the doubling intractable problem, which is a very important issue in contemporary statistics. Here I'm just giving you a brief description of the approximate exchange algorithm that myself and Niall proposed a few years ago. This is based on the exchange algorithm that was proposed by Mari et al. In 2006. So basically this algorithm is very is working very well in this context because it's just a sort of generalization of an MCMC algorithm. So the main feature of this algorithm, if you are familiar with MCMC, is just that instead of just updating the parameter value at each step of the MCMC algorithm, we also draw auxiliary data at each step of the algorithm. So to do so, unfortunately, we cannot sample directly from an intractable likelihood, but we can do that by using an MCMC procedure. So this is why it's called approximate exchange algorithm. The other thing is that we incorporate the information about the likelihood based on the new data, auxiliary data that we simulate at each step of the MCMC algorithm into the acceptance ratio, this way. This way, basically, we have the ratio of normalizing constant cancel. Otherwise, that would be impossible to perform a standard MCMC algorithm, as the ratio of normalizing constant wouldn't cancel. Okay, so model selection is, again, we are not focusing, okay, so far we've seen that this is an algorithm for sampling from a parameter posterior density, but we may want to also perform model selection. So basically, this is the intractable, doubly intractable posterior model. Now we are also including M of MH, which is an index of our competing models. So basically, the aim of model selection is just to calculate the posterior model odds. So if we want to compare two models, we can just calculate the probability of model H, given the data, divided by probability of model K, given the data. Where this is done by calculating that ratio. So the first ratio here is just a ratio of prior information about the models. So we set up those distributions, and then times this ratio here, which is called the base factor ratio, the base factor. So this is more or less the general. So we would like to estimate either target directly the model evidence, the probability of the data given the model, or either target the ratio directly. So in order to establish which is the best model, we would like to estimate the base factor, and then given the base factor, we can calculate the probability of each model given the data. If the ratio, for example, in this case, if the ratio is greater than 1, it means that model MH has a higher probability, posterior probability than model NK, and vice versa if the ratio is lower than 1. Then, when we have estimated the model, the best model, we have selected the best model, we have estimated the parameters associated to the statistics that we have included in the model. We would like to compare, we will have to perform Bayesian quantitative diagnostics. So the observed network Y, as I previously said, is compared with a set of networks simulated from independent realization of our estimated posterior density. So we have estimated a model and theta values. Then we can sample from the estimated posterior density some new parameter values, and then simulate based on those values, simulate new networks, and compare this set of simulated networks with the observed one. This comparison is done in terms of high-level network statistics, which are not modeled explicitly. So we can compare. We will see an example of these features. Okay, computational algorithms for doubly intractable problems. This is a very important research area in statistics. I know that many of you of the statistics guy are involved in this area. Many new approaches have been recently proposed, so the approximate exchange algorithm is just an example of a possible approach that can be used to tackle the issue of parameter estimation. The Bergen package for R implements the Bayesian parameter inference and model selection for exponential number of models using approaches based on the approximate exchange algorithm. So it's not just the naive version that I showed you, but there are also other further advanced methods always based on this exchange algorithm. So here I got a very briefly a toy example just to try to make you understand more or less the general aim of the beta model selection. So here we have a 16-node graph which represents the Florentine family marriage graph. So the connections represent marriage connection between Florentine families in I don't remember, in 14th century maybe, or 15th century. So basically we would like to estimate, we would like to compare these three models. So the first model is these are very naive and stupid models. So the models are, all these three models are including edges, so we are interested in modeling the density of the network. But then in model 1 we are interested in capture the transitivity effect, so we include the number of triangles as network statistics for our analysis. The second model we include 2 degrees, so the number of 2 degrees of nodes that have at least one two connections, and 3 degrees in the model 3, so the number of nodes that has at least 3 nodes as connected nodes. Then there are some details. I'm going to go through these. Okay, so basically these are the results obtained by the Berman package. So this is the model posterior density. So this is the density, the probability of each model, and this is the probability density, posterior density, associated to the parameters of the best model. So as you can see here, model 1 was selected as the best model, is the one having the highest posterior probability, and these are the distributions of the parameters associated to that model. Here we have also the base factor estimates. So the base factor 1, 2. So comparing model 1 and 2 is just 2.8, meaning that given the fact that we used uniform prior densities for, we used the same uniform model priors, this is giving us an indication that model 1 is 2.8 times more likely than model 2. This is giving us an indication that model 1 is more than 6 times more likely than model 3, and so on. We'll see probably these. I mean, this is a very stupid example, so I think Paul will show you much more interesting example. These are the parameter estimates, so posterior mean and posterior standard deviation associated to the 2 parameters, to the 2 effects of model 1, which has been selected as the best model. So as you can see here, we have a negative density value for the first parameter and a slightly negative, probably not significant parameter value for the second effect. This is the Bayesian fit test, basically. So the red line here is representing the distribution. So these 3 are 3 distributions calculated on the observed network and on network simulated from our posterior estimate. So this is the degree distribution, this is the minimum distance distribution, this is triad census. These are standard distributions that I use to perform the fit for social networks. So if we focus, for example, on degree distribution, you can see here the red line is the observed network degree distribution, while the box plots here are representing the values observed, calculated on our simulated networks. And we see that there is we can say that there is a good fit of of the model to the data when the red line is within the 95%, for example, and the interval defined by these box plots. So in this case, it's more or less fine. As you can see here, the red line is staying in the middle of the box plot, so this is a good behavior of the distribution. Okay, just to complete everything, so just advertising a little bit my package, the variant package for R, which is available on CRAN. I think it's the only one, the only package that was implementing the Bayesian analysis for ERGMs. Is implementing parameter estimation, model selection, and Bayesian diagnostics. So everything you may want to estimate on ERGM is available on that package. Tutorial paper has been recently published in a Journal of Statistical Software. This is freely available online. There are going to be a practical workshop on the BERM package at the Southern Social Network Conference 2015, which is going to be held in Brighton, I think, in June. So if anyone is interested, you can. It's on the first day of the conference, so it's a 3-hour tutorial on the package, and of course I will have much more time to explain the details of the software and the Bayesian social network analysis. Okay, I think that's it.
Okay, so we have some time for questions now. If anybody has questions for Alberto. Presentation is complete.
Okay, I have a little question about the model specification when you show the sort of.
Yeah.
Yeah. It's actually a little bit unclear. How do you find this model specific from? I mean, how do you compare this goodness of fit with this observation? And you mentioned that model specification is not included.
Sorry, model? Yeah, I mean, here we are selecting, in step 2, we are just selecting a set of statistics that correspond to some effects of interest. Okay. So generally you're interested in density, so you include the number of edges, transitivity, include the number of triangles, and so on. But then you have you're selecting features of the network that you are interested in analyzing because you know that they are important for some theoretical reason or also for practical reason. So you don't know if that model, that estimated model, is going to fit well the data at the end of the day. So this is why goodness of fit is performed, because sometimes you're interested just in a few effects, and then you can just have a very full fit of the data. So this is a useful tool in order to compare your belief in some sense of what would be a good model for presenting the data, not just focusing on the statistics that you are interested in, but with the overall topology represented by a lot of different statistics calculated.
Yeah, when you compare this overall topology, then you exclude the model specification.
No, you are including them. Yeah, so for example here, at the end, here you are just so for example, we used 2 stars in the model. 2 degrees basically are connected with 2 stars. So yeah, you're just calculating the entire degree distribution of the network, and you compare that with a simulated one. Yes. And the same for minimum distance. Oh, sorry, I'm not explaining the meaning of minimum distance in transcensus because I will. Time to do that, but I mean the degree distribution is very easy. It's just
Thank you.
The number of nodes connected with each node. Yeah.
Generally, there's some like metric which can measure how good the model is. It's just for this result, you can just visualize that if the simulates the results fits the real data. If there's some like index or metric you can give a value which can measure how good the model is.
Yeah, exactly. Yeah, for example, you can use RMS, MSC, like residual mean square error and stuff like that. Yeah, I mean here is interesting too because you can also have an idea of what are the anomalies in some sense of the Lipset network. So what are the type of statistics that are not captured by your model. So this is just a useful way to check how the. I mean, it's impossible to capture all the possible network statistics, because we would have to use a lot of network statistics. So this way is just a good way to check if what kind of statistics you are not capturing by including that model. But of course, everything is driven by the theory because potentially you can include statistics that are difficult to interpret. So even if you have a very good model, but it's very complicated and it's captured very well the topology of the network, then you have to interpret somehow the meaning of the network statistics. So.
Any other questions? Well, then Amanda. Oh, hey.
Sorry, I was late, so I'm just wondering, are you going to apply this for climate change, or
No,
how
I
is
think.
it related to your title?
So we have two papers today.
Oh, I see.
Yeah, and two speakers. So Alberto is giving an introduction to Bayesian modeling, ergo modeling, and ergo modeling. Paul is going to talk about an application of that
Okay.
modeling approach to climate change policy networks.
Hi everybody, I'm Paul Wagner. I'm going to show an application of how you can use Bayesian exponential and graph models applying to climate change policy making in Ireland. So just going to talk about why climate change is a political problem, then move from government to what is governance through networks, state my research, question the data, the methods I'm using, the analysis and the conclusions. So I'm just going to start by saying climate change is real. So it's not a scientific problem, the problem is how we react to it, so it's a political problem. 97% of climate scientists agree, nearly every single paper that's ever been published says it's happening, so the effects are both on people and on our environment. So the argument is that it's a political problem, not a scientific problem. So look at Ireland's response so far. Under the Kyoto Protocol, we are allowed to increase our emissions by 13% from 1990. The compliance period is 2008 to 2012, and we need to have an average 13% above this level for each of those years, which you can see that we achieved. So the emissions increased all the way up to 2001, then they were relatively stable, and then when the economy crashed, our emissions decreased rapidly, so we made our Kyoto commitments. In the last year, when the economy has started growing again, emissions have started to go back up. So where does that leave us? Under the EU, we are committed to reduce emissions by 20% by 2020, increase energy efficiency by 20% by 2020, and use 16% of all our energy from renewable sources. So if we only implement the policies that we've implemented so far, we're going to pass all or if we only continue on the path we're at the moment, we're going to exceed our targets in 2016, so we need to do a lot more than what we've already done. So this is what comes into the political problem. So what I'm arguing is that climate change governance in Ireland doesn't occur in a command and control type scenario, it occurs through networks. So the government develops policies in collaboration with organisations and stakeholders that are involved in arguing their case or putting forward proposals. So just the complexity, uncertainty and disagreement constitute a foundation for wicked problems that can be best tackled through collaborations between interested actors that are built on trust, shared norms and opportunities to exchange information. So it's moved from a scenario like this, which was a normal way of, say, analysing it in the 1970s, 1980s, where you have the government departments, and then below that even more. Now we're looking at a more scenario like this, where the political parties engage with all sorts of actors, the government departments engage with all sorts of actors, and they try and develop policies in coordination or competition. So, why do actors create, maintain, dissolve and reconstitute network links? So there's a lot of reasons why somebody would create a tie with somebody else in the network. Either out of their own self-interest because they're trying to get a policy implemented that they favours them, or they might cooperate in groups when they're trying to overcome the fact that more powerful actors have bigger say, so if they work together they can get what they want. Theories of social exchange, which might be trading favours, or resource exchange, which is trading money or information or access. Theories of contagion, so you might start creating a tie with someone, and then I'll create a tie with someone, and the next person will create a tie because everybody thinks they're important. There's theories of balance, where you might have, the government might create a tie with someone who's opposed and someone who's against. Theories of proximity, which is you might create a tie with someone who's in a geographical location similar to you. Or theories of homophily, which is I'm going to concentrate on today, which is you create ties with somebody who's similar to yourself. I'll talk more about that in a minute. So, are there forces that can explain why we observe particular policy network structures? So there's a lot of research being done on this and why people create ties in policy networks. Some people argue because it's trust, other people shared ideology, other people strategic behaviour, so you might play people off each other in order to get an advantage. Other people might try and only gain access, so they might go for people who they think have institutional power, so government, political parties, or certain bureaucrats in certain political departments. Or you might engage with those in structurally advantageous positions. So if you're quite weak, but you know this person has good access to someone important, you might go to them and try and influence them to influence the next person. So there's a lot of different reasons why somebody would be driven to create ties with different people. So this is data that I've collected from 52 organisations in Ireland. And the red dots are the organisations, the lines are, I asked them one question, who do you cooperate with? So the arrow means that they cooperate with each other. So for example, Sinn Féin and Stop Climate Chaos, which is a kind of a lobby group, they've both said that they collaborate. But you can see Sinn Féin's out here, all the action is happening up here. So the question I want to know is, why do we observe this and not something else? So what are the forces that drove this to emerge? Where did it come from? So, you know, as I said, there's a lot of different reasons why people create ties. So, what I'm going to argue is that there's two different types of homophilous relationships that can occur in a network. I'm going to test them to see which one of them is more likely to be driving the behaviour in the Irish policy network. So the first one is value homophily, which is the idea that people choose to collaborate with people with whom they agree with. So you might get into coalitions. So you'll have a group over here who are pro-environment, another group over here, you know, pro-business, and they're not so much in favour of policies that are strong. Then the other type of homophily is status homophily. So this refers to you might engage in cooperative behaviour with somebody who has similar characteristics to yourself. So businesses are working together over here, NGOs are working over here, government departments are working over here, but they don't necessarily agree with each other. They've just separated the complexity of climate change into separate little subsystems, and each of them are resolving different problems. So in the business group there might be, you know, green businesses and other businesses. They disagree, but the ties are being formed because they're similar, whereas the values are being tied because they agree with each other. So that's the main difference. So common preferences bring actors together, and common characteristics lead to common behaviour leading to tie formation. So these are the two competing models. So let's talk about them a little bit more. The value homophily in policy networks can be described using this advocacy coalition framework, which describes the tendency for organisations to split into opposing groups with dissimilar preferences. So over here you'll have the environmental groups, over here you'll have the business groups, and they compete against each other. So the network in Ireland is fragmented into a number of different groups that oppose each other, and they don't really listen to each other. So that's one argument. The second argument, the second hypothesis is the sectoral view of the policy-making process, which contends that the reaction to climate change has separated the network into a number of different subsystems, within each of which there's a number of different debates related to the area that they have knowledge, specialised knowledge about. So the business groups are, you know, debating issues that concern business groups. The government departments are having kind of a debate amongst themselves how to react. Political parties are engaged in debate in the legislative politics, bureaucratic politics, business politics, environmental politics. They're all kind of separate but interdependent. So they're not completely separate because there are some links linking them together. So the data that I've collected, as I said, is 52 organisations out of 57. I asked them, with which of the listed organisations does your organisation cooperate? Asked them their preferences on a whole range of questions for national and international policies, carbon taxes, carbon trading, a whole range of different things, and an actor type variable. So which type of organisation are they? So now to talk, I'm just going to talk a little bit about the method. So in social network analysis, there's descriptive statistics, which I'm not using, which is basically summary measures. So who gets the most ties, who sends the most ties, how many triangles are there, how centralized is it, is there a periphery, all these kind of things. But they don't tell you what drove the creation of the network, how did the network emerge, where did it come from, what are the things that cause people to create ties. Which I'm checking is the two types of homophily, which one of them is more likely to be driving tie formation. So I'm using the Bayesian approach, so you model the micro foundations, so you look at the small level types of actions and how do they all add up interdependently to what you get at the macro level. And then when I run the two models, you compare them to see which one is better using the Bayes factor analysis. And then using that you can extrapolate and simulate from the model to make sure that the results that you have adequately replicate distribution. So, just take a drink. So the way that it works, just quickly summarizing it, is you have the observed network, which is the network that I collected the data from. And if you think about it like a regression, it's quite similar, kind of. So you have the observed network here, and what you're trying to do is simulate to that. So what are the variables that when they interdependently act, how do they create the network? So you're not trying to, so in a normal regression you might have income, gender, geography or whatever, and you predict the income based on that. In this you have the income already, and you're trying to say what type of factors created what you observe. So using these models you can investigate multi-theoretical hypotheses, so each of these types of substructures are equal to a certain type of behaviour. And then because it's a Bayesian approach, you don't calculate p-values, you get the plausibility of an event given incomplete knowledge. The parameter mean estimates are kind of a weight of how important each of the things you put in the model are. So if it's really high, then it would mean yes, this is important, there's a tendency for this type of behaviour to happen. And then you can compare and contrast the different things that you put in the model to see which ones are better, or which ones tell you more. So these are the steps. You develop a model that hypothesizes what drives tie formation, which are the two that I'm talking about. You set the priors based on knowledge about the parameters. So because it's Bayesian approach, you start with what knowledge you have. So I put them as 0. So I'm saying I don't have any real knowledge, and I'm just going to extrapolate from the data that I have. And then I ask, do the conclusions support the hypothesis, evaluate the fit of the model to the data. So this is the process. And then to compare them, you calculate the Bayes factor score, as Alberto said earlier. So I'm not going to talk about that, but I think the numbers you just need to know. So if it's 1 to 3 or 3 to 20, so what I want to get is a number like this, to show that the model that I have is better. So the two different models that I have, so each of them have a number of, say, similar to a control variable. So these are types of statistics that I'm going to include in the model in both of them, so that they don't, because these types of behaviour happen in every policy network. So the main ones you have to look at, these are the additional ones. So one of them is the status homophily model, so the 6 actor types, and the other is the value homophily model, which I'll talk about how I calculate the policy preferences in a second. So the control variables, so there's a tendency for edges to be formed, so that's the first kind of variable that you include in the model. The second one is a mutual, so there's a tendency for people to reciprocate ties. If I say I cooperate with you, you say you cooperate with me. There's a tendency for that to happen. The GWESP is a kind of a way of modelling a distribution of triangular relationships, but it's curved, which basically means there's a tendency to creating groups, but once you create too many ties, then you stop creating them because the cost of doing so outweighs the benefit. So if I cooperate with 2E, then the 2E, but eventually it takes too much effort to cooperate with more, so I stop. I just do it until it makes sense. The two-path models the tendency for there to be a policy broker in the model. So for example, we have two different groups, there'll be someone in the middle who kind of links them. So like a government department might be kind of helping two people work together. Or they might not even be working with them, but they take information from both of them. So these are in both models, because these are the kind of behaviors we expect in a policy network. In the first model, we have actor type, so each actor has been put as an attribute variable, and they're categorized as one of these 6 different groups. The preference similarity is a little bit more complicated, how I calculated that, but let me just quickly go through it. So I asked each organization, say 24 questions on their preferences on a range of policies that affect Ireland, national policies. Using on a Likert scale, so -2 to +2, strongly agree to strongly disagree. Used a hierarchical cluster algorithm to calculate a dissimilarity matrix, which means the distance between policy preferences. So if you said strongly disagree and I said strongly agree, that's a distance of 4. If we both said neutral, that's a 0. So you added them all up for every single question. The larger it gets, the further away from each other. So then you calculate the maximum, and then you just take away the dissimilarity, so then you're left with the similarity. So the lower the number here means the closer they are together. The more questions that they answer similarly. So you can see 9, see these are the actors here, so you see 1 and 1 is that's himself. So that's the same word, but they're 0 because they answered all exactly the same. So this guy 10 and number 2, and at this distance where he's much closer to here in number 3. So there's a lot more answers in common. So just go through them again. So edges is kind of like an intercept in a regression. The mutual it captures the tendency for reciprocating ties. GWESPs is the tendency to form groups, small groups. This is the tendency to capture multi-connectivity, so 2 paths, so from me to you to the next person, like that. And then this is the same actor type, and this is the policy preferences. So these 4 are included in both models, and these are included in one each. So these are the results. You can see the Bayes factor score here shows that this model is much better than this one, but much better than the value homophogy model. So basically, we can see from this at the edge, -3.96 means there isn't a tendency to form ties. The density is quite low, which means that not everybody's connected. There's only a few connections in the network out of all possible connections, and that the other variables in the model capture much of the tie formation that occurs. So mutual at 1.21, so there is a positive tendency towards creating mutual ties. GWESP means there's a positive tendency to create triangles. The negative one on GWDSP means there isn't a tendency for me to be linked through multiple different people to the third person. So there's only a few people who act in the middle. So say there's only a few people who act as brokers. Right? If it was positive, then I would have multiple ties between. So the utility of the person being in between people is low, because I can go to someone else. There's multiple paths. Node match, it doesn't add a whole lot to the model, but it is significantly better than just having a model like that. If you look at the edge covariate here for the value homophily, it's almost 0, which tells us that having shared policy preferences doesn't really predict type behavior. So there's pretty much no relationship between, if I agree the same things as people, it doesn't mean I'm going to create a tie with them. It actually means that there's very little difference in the preferences of everybody in the model. So everybody is quite in agreement, so you can't really predict anything from it. If it was strongly positive, it would mean you could tell that they create ties. Strongly negative would mean that people are creating ties with people they disagree with, for whatever reason. So, what does the network look like if we put on the actor type? So, each of the colors represents one of the 6 different groups. So you can see here the blue, which is the energy group. You can see they're pretty close to each other. Or sorry, that's a business group, so they're all reasonably close to each other. The energy group is the purple, so they're pretty close. The pink is all the government departments. The green is all the NGOs. You can see the research institutions are orange. They're not really collaborating. And the government and all the political parties, the yellow ones, aren't collaborating either. So there's no, so that, you know, there's a couple of different kind of debate. There's a debate going on between business groups, there's a debate going on between energy groups, and the NGOs are up there. Maybe they do share policy preferences, but the tendency is not to tie with people you agree with. The tendency is to tie with people who are engaged, who have specialised knowledge similar to your own. So, using these parameter estimates, you simulate a distribution of networks to see if your model is good. So you first of all try to simulate to the model, and then you go backwards and see if you can. The red line is the kind of distribution of these instances of structures that aren't in your model, to see if you can do it backwards. And if it's within the distributions, then you've got a good model. So this one, you know, is not so great, but it's within the 95%, so it's not too bad either. So what is the consequence of this for policy making in Ireland? So if you had 2 different coalitions or 3 different coalitions, the government would have to act in a certain way. They'd have to, you know, see what the fight is about, try and kind of find some kind of common ground or something like that. But with a subsystem like this, you know, there's a number of different debates going on all over the place. So the government isn't trying to play people off each other. They have to try and find out what these people are talking about, what these people are talking about, what these people are talking about, and then try and understand, you know, what each of them are doing, and then try and create a policy, you know, that accommodates the different people. So there might actually be a lot of agreement. 90% of people might agree with a certain thing, but because they don't know, you know, who believes what, they're not collaborating with each other. So, the argument I'm left with is the capacity of the government to manage climate change will depend on how well they're able to coordinate the actions and interactions among and between the subsystems in the network. Thanks.
Thank you, Will. So we have some time now for questions. Yes.
Can I ask, how did you get such a good response rate? Because
Persistence. It took like 4 months, and it was a lot of emails, phone calls.
Threats.
Yeah. It started off well enough with NGOs and then research institutions, and then kind of plateaued for about 2 months. But then once you start getting a few of the government departments, then you can say, oh well, I got these guys, and a lot of businesses didn't want to do it, but then you say, well, you know, these people gave me information. If you don't, you know, you'll be left out. You know, and I think your voice is important.
so I suppose it's also not just it's not just which company you're speaking to, organisation, but getting to the right person within that organisation as well.
Yeah, most of them have somebody who's responsible for policy, so, you know, and a lot of them are actually, you know, they're glad when someone calls them up and they can share their opinions, because usually nobody asks them anything. And as well, if they can get it, you know, 2 hours off work and say, oh, well, I'm involved in research, then, you know, it's a change for them as well.
First and then Messi.
So I have 2 questions. The first one goes back to your hypothesis. I'm not quite sure why. I have a feeling that value homeopathy, it's a part of status homeopathy. So basically, I'm not sure why there should be a difference. If they have a different status, probably people or probably groups that have similar status will also have similar-minded values.
Well,
so basically, you need to probably show that there is a difference between these 2 measures, I guess, value and status.
Well,
so what I could see from the table was that they were all structured together somehow. So basically, it's like, yeah, all of them looks like they are just structured together.
Well,
so those are all different status.
Yeah, but it means that the tendency for the people of the same type to create a type is, given that they already engage in other types of behaviours, that on top of that, this is even predicting.
Yeah. I would say that value is a part of the statue.
Well, if you think about it like this,
like
everybody in here would have some kind of status homophily because we're all involved in research, but we're all may have different opinions about the utility of this research. Whereas if you ask somebody who studies policy network, well, say somebody who believes the same thing, then they'll say, oh yeah, no, this is all valid. But like maybe half of you hate this and half of you like it, but we're all researchers. So I think that's the difference. It's between, we're all here because of what we do, not because of what we believe.
Okay, and the second question is about the number of organizations. You said 52 organizations and you had 10, I guess, of each of the departments or different agencies. Why is that? But you never mentioned why is that, well, how did you get to those, why are those 10 NGOs important? How did you get to those numbers? Why not others?
Yeah, so a number of different ways. So there's a lot of government consultations when they're developing policies for climate change. So there's like maybe 5 different, you can see online who submitted their opinions to the consultation. I also interviewed Ireland's negotiator with, in international negotiations, an economist worked in UCD. I also interviewed a guy involved in climate science.
They are representative of the sample. I mean, this sample is
No, this isn't a sample. This is everybody who is...
Everyone in Ireland?
No, everybody who was deemed important. I had about 10 different sources, and I cross-checked all of them to see who's coming up. Because some organisations come up once, like some kind of Catholic organisation, but then when they interview the 4 different experts, they say, well, this guy isn't influential. So then when I had like 11 different lists, and then whoever showed up on 3 of them, I said is important. And as well, when I interview people, I ask them, is there anyone who's not on the list you think should be on the list? And nobody mentioned anybody. Yeah.
Actually, and Asim, I think, was next.
Yeah, it's okay. One of my questions has already been asked, like why you have the number 14 and 12.
Oh, that's just 12 out of 14, 8 out of 10.
Yeah, and another question is about these political parties. What is BENE, and it is just...
The
Yeah.
one that's by itself?
Yeah, it's just alone.
Yeah, that's Better Environment for Nuclear Energy. So it's an NGO that advocates for the use of nuclear energy, and they don't collaborate with anybody and nobody collaborates with them.
Yeah, thank you.
You can put a variable in a model for isolates, which are organizations by itself, but because I know there isn't a tendency for people to work by themselves just by looking at the data, you don't put it in. But if you know, in another network, policy network, there may be lots of different individuals, so it might be an important driver. You pick what you put in the model based on the theory.
My question was quite related to that table that you showed there. You said you chose it based on types, actor types, but obviously you had a list of individuals. So did you look actually into submissions, who was writing the submission, or did you actually get the names, or did you get the organization?
They're submitted by organizations, and then when I met with the people, you ask them, what's the policy position of your organization? So some of them, for example, had their own policy, their own preferences, but they don't tell me that. They say, well, I think we should have a carbon tax, but the stance of our organization is there should be no carbon tax. So that was explicit when I asked them the questions.
Okay, so they were giving the preferences based on their organizational affiliation.
Well, yeah, of the organization.
Yeah. So that might have influenced your results, no? Because
Well,
I know, for example, I collaborate with people in Chagask, and I know they will never say, they make a policy statement that is not in alignment with what Chagask is saying,
Yeah.
So they have to say it that way. It's completely out of question to say something else.
Well, I think that's what I'm trying to capture. What's the policy?
Yeah, but the status in that case is completely overlapping with the preferences.
No, I wouldn't say so. Well, because if the preferences were overlapping, then you could say that, or if the preferences are overlapping, then why do we get no knowledge from the preferences? That doesn't tell us anything about who they form ties with.
I mean, it's very useful to know this, but I think it's not too surprising that that you got the status? I mean, maybe it's also in hindsight that we can say, but it's not too surprising because, for one, if there is I don't know, maybe it's just a wrong perception of mine, but I have sort of the impression that there's sort of a protocol of consultation as well. And there will be, within government, there will be a protocol of consulting, first of all, with other government bodies.
Oh yeah.
Because, researchers most likely would first of all consider, consult with other researchers and so on. So.
Well, I think because in each of those groups you could see that the government departments are collaborating. So you could say, oh yeah, they've negotiated among themselves what the government department's line is. But the data shows that they don't agree on things. So the Department of Agriculture might argue one thing, and the Department of Environment will argue something else.
Okay.
Yeah.
Yeah.
You mentioned a list of theories in the beginning. Just sort of curious, like, could you use a simulation of a network approach to sort of think, like, maybe to get to validate which one of those theories would, I know you've done that with Hamilton part, but has there been other work that's been done in other parts?
Yeah, lots of people have looked at different things, and then the different types of structures are why different people. So, for example, this one with institutional power, you'd expect people who have, say, you might have the actor as a government department, and they'll receive lots of incoming ties, but they might not send out a lot. So everybody's trying to say, oh yeah, I collaborate with them, but they don't send anything back. Whereas this one, they might look at, there might be a lot of people who are, directly connected to someone who's influential. So you see a lot of people engaging in that. I think nearly all the research that's been done on this kind of stuff, nobody else has found, and nearly everyone finds policy preferences drives tie formation. So the fact that that doesn't happen in Ireland was quite surprising, because normally you cooperate with people who agree with you. So that was, and the fact that here, maybe your experience is different, but all the research that I read shows that that's what happens.
Well, actually, I mean, if I may say something, like, from my experience being a foreigner here, I have the impression that you collaborate more easily with people who have a similar background. So, like, if you male with males, if you female with females, if you foreign with foreign, and so on and so forth. So I have it's just my own personal experience. So in terms of preferences, we wouldn't necessarily agree on policy preferences, but we would maybe agree on gender or cultural background or, things like that. So.
Well, I think the difference between an individual's preferences, I have friends that I disagree with, but in something that's supposed to be rational, like policy making, where you're supposed to be weighing up evidence, it's most rare.
But in terms of the network building, like the network building, the professional network building.
Yes. Well, I actually haven't seen any other papers that had even tried to model, status homophily. So that's the main reason I did it.
Well, I wondered if you could simulate a distribution of policy preferences which was much more heterogeneous, and then you tested this, you used the same data, network data, almost like a benchmark.
Yeah.
So you imagined an Ireland with heterogeneous policy preferences distribution. That's a thought.
And just from reading the data, I can tell that most people agree with each other on nearly everything. But then there's like one or two things that everybody is against. The two things that affect them, they say, no, we don't want that, but I agree with everything else. So the fact that the policy preferences are all similar, doesn't mean that there aren't disagreements. The disagreements are based on, everybody's in favour of doing something against climate change as long as they don't have to do anything.
Sorry, I didn't make that. Adding something else. You asked the question, who do you cooperate with regularly? Did you ever
delve into how they cooperated or what they did
Yeah.
together?
I have more data on, I asked them who do you get information from, who do you give information to, who do
That's
you get
it.
policy advice from, who do you think is influential, who influences you. So I have another chapter on my thesis that looks at how deeply connected people are on multiple levels. And basically the finding from that is that the green group is very well organized and then the rest not so much. But because, as you can see, the Greens are out there on their own, they're not really very influential.
Well, did any of the organisations tell you why they may not coordinate with others, or is it just an Irish thing, or do they feel they're better?
I didn't ask them. No.
So it's not maybe when you trying to ask people the attitude about the 24 questions you ask. So when they answer questions, they represent the organization where they belong to. So they tend to give the answer which kind of gentle or neutral. They don't want to really express their real opinion.
Well, I think if you're engaged in a kind of a policy making process where you're trying to get what you want, you have to tell people what you want, because if you don't, how do people know what you want?
Yes, when they answer questions from the participants, they made it just to give some people some questions that everybody can accept.
I mean, a lot of people gave neutral answers because they don't have a policy position. So you ask somebody, from the energy sector a question about agriculture, and they say, well, it doesn't affect me, so we don't have a position.
I was just trying to explain why you get from the question now results everybody agree with each other very much, but actually they don't cooperate. It could be a reason. No.
Well, I think that when you're cooperating, you only have so much time and resources, so you have to be strategic about who you cooperate with, because you can't, you don't have the resources to cooperate with everybody.
Question. Are you going to present your research results to the policymakers in Irish government? Try to influence or lobby them with the policy-making process?
No. I think there's nothing that... There's a lot of this, I think people who are involved in it will kind of know, maybe subconsciously, that they know what's going on. But nobody's got all this data to analyze it. People would know, if you're an energy company, you know that who you're cooperating with, and you know what's going on in the other areas. Yeah.
Yeah, actually, I'm not sure I would agree with that, because that the government is not interested. I would say, for example, the EPA would be very interested in this data, because they are really trying to find out how can they enforce a culture of evidence-based policy making. And especially the chapter that you haven't presented on where do people get the information, that is very crucial, I would say.
Yeah, most people are getting information from the same 5 or 10 sources.
Yeah.
So the problem with that is, everybody's getting it from Chagas, EPA, ESRI. So there's 10 different organizations, so everyone's reading the same things. So I think, in one sense, maybe people's preferences are being shaped by the fact that everyone's reading the same information.
You better make sure that information is
there's
very up to date and very good.
People trust the research institutions, I suppose. But I'm not a climate scientist, so I believe it's real. But I can't. I'm not an economist either, so I haven't evaluated the pros and cons of each policy.
Can I come in on that? I think, to be fair to Paul, he's just writing up his PhD now, aiming to submit hopefully in May. I think it's deadline. But I think the idea of presenting the findings, Paul, was a wonderful idea. But if this is one project, we have another project quite similar to this, but it would be very nice to putting this out as an invitation to folk in UCD or elsewhere, you know, if there were a few different papers that we could put together
But
as
there's
a little workshop on
the Environmental Society of Ireland or something has a conference in March. You have to pay €100 to submit an abstract.
Well, if something here at
Submit
UCD
an
that
abstract.
we could organise, I'd be very happy to. If there's a few of you writing and doing research in this area, that would be really nice. Put something together, maybe over the summer or something. So I'm happy to coordinate something like that if there's a few people interested.
Just to add that you say that they know exactly what's going on, but what they perceive as going on may be quite different from what you have there, and that in itself would be quite interesting, the whole notion of eco networks versus what actually is. So
Yeah,
you
because
might surprise
there was
them, you may
people-
not, but you might surprise
I mean, there's
them.
plenty of people when they're doing the survey, they're like, who are these guys? I've never heard of them. You know, and they're like, what do they do? They've got nothing to do with climate policy. But you know, you can't know everybody.
Yeah, I would say it's crucial information. But you know, publishing it is one step, is a good step. So just write up your thesis and then we'll go from there.
But I've submitted the other one to a journal, but I haven't heard back from them yet.
Okay.
So
Any other questions?
What are the implications of this research?
well, the implication is what I was trying to say at the end, that the government aren't looking at, you know, different opposing, like in America you might have, you know, you'll have a right wing and left wing, well, left, you know, American left, that are fighting it out over what they should do. Whereas here you don't have two different factions fighting it out. What you have is a number of kind of little discussions going on in different sectors about what they should do. So some of them might fully agree with each other, like all the green groups might agree with each other and everything, but in another group they might not agree with each other at all, they might be split in two. Because the reason we know that is because we tested it against preferences, so we know the preferences aren't influencing it. And actually the Bayes factor score was, I say it's over 150, but it was 3,000. So it's actually 3,000 times worse, right? 2,886.
Okay,
The cameraman has a
no,
question.
you.
Yeah, so it's saying, like, you know, similar models run in other countries would show how those relationships between agencies would work. So does this illuminate, you know, particularly in Ireland, the Irish experience in which these types of negotiations or understandings are made? I mean, for example, you know, would this be useful to follow, say, how policy around the removal of the quota system in milk is perceived from an environmental point of view compared to another country, say the United Kingdom? Not the dairy production itself, but the negotiation between, you know, what does this do to carbon levels if we move towards more dairy? Does it help, you know, what are the arguments?
You can use these kind of models, but because the reaction to climate change in each country is going to be different depending on the economic and political social structures and the type of economic interests and political interests, or whether it's a federal government or a unitary state, or whether they're part of the EU or whatever. So the theories that you would use to describe the model is going to be, could be completely different. And, you know, I don't have a huge knowledge about, you know, the British political system, so I don't know what theories might be best to model it, or which actors are the most important.
So it might also be interesting to compare that process then in Ireland on another issue.
Well, I'm involved in an international research project called COMPON, and there's 20-something countries involved in it. We've all collected the same kind of data, and then we're all analysing it in whichever way is most appropriate for your country.
Because it seems just as a joke almost, but the absence of the little brown envelope symbols there as that metaphor for, you know, how decisions are made in Ireland, and of course a model like that's not going to show that, but it might show that something is happening that is not really explainable by expected.
I mean, there might be lots of institutional rules and processes that this model might capture, but it might not capture what happens in the background. So, you know, everyone has to submit to the consultation, and then they have an Oireachtas committee, and then people go and talk at that, and then they make some changes, or not, as the case may be. And, you know, that's the official process, but that might not be. It might be just Fine Gael in the back just writing up exactly what they want, and then do all this for show.
Yeah, but it's very powerful that you can show that these were the interactions, this was the outcome, and let's scrutiny that to see what is going on. Great.
Okay, so I think, oh, you want more question?
From this table, you'll say BF is larger than 6.1 and larger than 150. You compare for 150. You compare the model 2 to control model.
Yes.
So from this table, we see model 2 is the best.
No, model 1 is better than model 2, and model 2 is better than model 3.
Oh, okay.
So even the model that doesn't put in the policy preferences does a better job than the one with the policy preferences.
Okay, can I have a round of applause for the speakers?